In the previous video, we talked about what the Pythagorean identities are. One of them was the cosine squared theta plus sine squared theta is equal to 1. Let's use this identity so you can see how useful this is for finding different values of a trig function when we're given one of them. Let's say that the problem tells us that the sine of theta is equal to 2/3. And theta is some angle in the second quadrant. How can we use this information to find what is the cosine of theta? Let's try. So the cosine squared theta plus sine squared theta. Well, sine of theta is 2/3, so I'll replace it, I'll substitute it, and then square it. The sine of theta is 2/3, but this needs to be squared because in the formula it's sine squared theta. All of this must be equal to 1. So we have the cosine squared theta plus 2/3 squared becomes 4/9 is equal to 1. Now we'll subtract 4/9 from both sides. The cosine squared theta is equal to 1 minus 4/9. You get a common denominator, that's 9/9, so this is 9/9. 9 minus 4 is 5. So the cosine squared theta is equal to 5/9. How am I going to isolate this cosine? I'm going to take the square root of both sides. So this becomes the cosine of theta is equal to plus or minus the square root of 5/9. When I have a radical of a fraction, it's the same thing as the cosine of theta is plus or minus the square root of 5 over the square root of 9. The square root of 9 is 3 because 9 is a perfect square. So we have the cosine of theta is equal to plus or minus the square root of 5 over 3. Now how about this plus or minus? How are we going to decide which one to use? To do that, we go back and we use this information. Theta is in quadrant 2. What is quadrant 2? Well, quadrant 2 is over here. That's quadrant 2, there's quadrant 3, and here is quadrant 4. When I'm in quadrant 2, look at the x values. What are all the x values in quadrant 2? All of the x values are negative, and so all of the cosines in quadrant 2 must be negative. Therefore, the cosine of theta is equal to a negative radical 5 over 3. This is giving us the cosine. We know the cosine because it gave us the sine. What if we wanted to know the tangent also? Do we have to go back and use a different trig identity? We could. In the previous video, you saw there is a Pythagorean identity that has the tangent in it. There is a faster way though. How could we get the tangent? Well, the tangent of theta is equal to the sine of theta over the cosine of theta. And so we can just substitute. You know that trigonometry is one big exercise in substitution. Let's substitute our sine of theta. The sine of theta is 2/3 right there. So I'm going to put in 2/3 over, what did we get for the cosine of theta? That's right here. That's negative radical 5 over 3. I'm dividing a fraction, two fractions. What do we do when we divide two fractions? Well, we have to multiply by the reciprocal. So this is 2/3 times the reciprocal here. This is 3 over negative radical 5. These 3's cancel out. We end up with 2 over negative radical 5. Let's not leave any radicals in the denominator, and we'll end up with, I'll multiply the top by radical 5 and multiply the bottom by radical 5. We end up with 2 radical 5 over negative 5. This is the value of the tangent of theta. What would you do to get the secant, the cosecant, and the cotangent? Well, those will be even easier. All you have to do is take the reciprocals. I'll do a couple of them just so you can see. So the cosecant of theta, well, that's the same thing as 1 over the sine of theta. That's just the reciprocal of the sine. What was the sine? Well, the sine was 2/3. The reciprocal of that is 3/2. So the cosecant of theta is 3/2. And how about the secant of theta? The secant of theta is the reciprocal of the cosine. What is the reciprocal of negative radical 5 over 3? You're right if you said that it is negative 3 over radical 5. We don't like to leave radicals in the denominator, so I'm multiplying the top and the bottom by radical 5 to rationalize the denominator, and we end up with negative 3 radical 5 over 5. That's the secant of theta. That's the process that we use to find any of the trig functions we want as long as we are given one of them and which quadrant the angle is in.